In this video, we'll start with the Bollinger Band analysis. So we'll talk about Bollinger Bands. To construct the Bollinger Band variable, first we need a moving average variable. So for this, we'll use maybe 20-day frequency. So we'll create 20-day moving average data. Very easy. We have already seen it, how to create it. So roll meaner and then closing. We'll use Amazon close and then specify the period as 20. So this is our rolling Amazon mean. So here we can see. Next, we also need to add the standard deviation data. So we have the standard deviation and we'll use the roll apply. In the roll apply variable, we'll use our Amazon close prices, but with this close prices, we'll add the standard deviation and with a width of 20 days. So we'll use a width of 20 days. Function will be st will equal to na. So if there are any unavailable values, we'll use na. So we have our standard deviation ready. Now we need to create our Amazon Bollinger Band variable, bb variable, and we'll use the cbind command. So first series will be Amazon.close which is Amazon the closing price. So I'll use it directly. The closing price series we have, that is the first data point. Second data point is Amazon MA20, and lastly we have standard deviation data. So we'll combine all these series. Let's name them. So call names, the very useful command call names, where you can specify the and you can provide the names Amazon.close. Next you have Amazon underscore MA 20-day MA. And lastly we'll add this standard deviation data. So we have given the names. Also sometimes with these analysis na is not available, observations may crop up, so you keep on adding this na.omit command so that there are no unavailable observations. Now we'll add the upper and lower bands, and before that let's check if there's any issue with our data. The heads and tails are properly appearing for the Bollinger Band data. Yes, they are. So we have the head and tail and standard deviation. So all I need to do is add the upper and lower limits of the Bollinger Bands. If you would have seen Bollinger Bands, you would recognize that we need that two standard deviation above and lower limits. So first we are using 2 standard deviation, but you can add a higher or lower value as well. So first is our Amazon Bollinger Band 20 moving average, and the upper limit will be summation of 2 into standard deviation. So we'll add the standard deviation. Similarly, the lower limit would be minus. That is the only difference. So the lower limit only difference will be a minus sign will appear. So we have our Bollinger Band data ready. Now we start with plotting the data. So to plot data, we'll make use of this plot command. So we'll use this plot, and again x is index, this bb data, the dates are indexed. We'll add the x-axis as date, y-axis as close, and ylab as price. That line type as L, and maybe a line width of 2, Now we'll give the central heading, which is main equal to Amazon Bollinger Bands for 20 days and two standard deviations. The period is Jan 1st 2013 to December 31st 2013. Notice that I specified a particular period. So how do I ensure that this period is followed? We'll see that. So for this I need to specify the range. Wherever I want to zoom in, I need to specify the x range variable. So let's call it range dot x, which is equal to as dot date see 2013 December 31st. Similarly, for the other end is 2000, sorry, it was January, so I'll use 01, and the other range is December, so 12 and then 31st. So this is our range of x-axis. Similarly, you can specify y-axis also. So for example, let's say I want to specify y ranges 60 to 100. We can adjust it later on as well if we find that details are not so proper. So this is my y and x ranges, and in fact I need to provide ranges here itself. So I'll add the range dot x, and this is my x lim. So I'll specify that x lim equal to range dot x and y lim equal to range dot y. You can adjust these x and y ranges as per your requirement or your understanding of data so that your plot appears proper. So this command will be used to draw the plots. So because there was no plot, I'll change this window a little bit from 0 to 50 so the plot appears proper. So let me add the ranges now and also the y lim. In fact, let's first examine the plot before these limits to see what ranges. So it seems that this particular range from 18 to 20 is more proper. So rather I'll focus on the period 18 to 20. Let's see how it appears. And also the prices in this range from 50 to 200. So I'll use 50 with. So this is more appropriate to just see the data how it appears and then plot it. So now I'll put x lim equal to range dot x and dot y. So again it has misfired. So let me rather just put the x-axis, focus on x-axis. So this is also nice. So this is also fine. Also, I think I need to change the plot central heading as well. The next thing would be to add the lines that are needed. So I'll add moving average lines. So first, using this lines command, let me add these lines command. So I'll add lines command to specify the x-axis first. Then I need to specify the y-axis, which is Amazon underscore BB, and I'll use the first we'll plot the moving average plot with line type equal to 2 and maybe a color of blue. So we'll add this, and then the next thing that we need to add is upper band. So we'll add the upper band in maybe green, so green for upper band, and similarly red for the lower band. So we'll add the red color for the lower band. So these are the lines. So let's start with the plot. See if our plot is appearing properly and robustly. Yes, it does. Better let's add LWD equal to 2, so probably it will appear more solid. Let's see. Yes, now they are slightly more visible. The very last important thing you want is the legend here. So you add legend. It seems that maybe bottom right appears to have some extra space. So bottom right, and then I need to specify the legend names, which is Amazon closing price. So we started with Amazon closing price. The next is 20-day MA, and then we have the upper band, and lastly we have the lower band. We need to specify the line type, so although I'll ignore the line type here, so or maybe I do. So line types are mostly two only, so I'll use 1 2 2 2. Then I need to specify the color. Are colors black, blue, red, and lastly green. So these are colors. I'll also specify the fill here. For the fill, the same parameters can be used. Okay, so this is done. So let's see if we are able to add the color. So let us plot the complete thing. So we started from, we'll not use this range window, it's only the X range is useful here, so we'll use the X range and add the legend. So a nice, very nice plot. We can see how Bollinger bands are moving and we can zoom in on the plot. The way to interpret it, look at the behavior of the black solid line, which is the closing price, vis-a-vis the green plot, which is the upper band and lower band. Whenever the signal, this is, you can also call it a signal line when it just crosses over from the top for the green or crosses over from bottom to the red. And also you can interpret in conjunction with the blue line, which is the 20-day MA, and black line, so you can combine them. For interpretation, you can refer to the theory videos discussed earlier. In this video, we'll start with relative strength indicator, a very important measure. So we'll start with relative strength indicator. So first we need to have difference in prices. So we use the diff command to compute the differences. In the first, we'll start with Amazon closing prices. We'll compute the difference. Now, as part of this RSI or relative strength measure, we need to compute up movement. So we'll first create an up variable, which is 1 if this delta is greater than 0, else 1 or 0. So if delta is positive, then it is 1, else 0. Similarly, we'll create a down variable in a very opposite manner, where if delta is less than 0, the value is 1, else 0. Now we'll combine these in the Amazon RSI, which is equal to cbind dot close, which is equal to closing price, and then we have our delta variable up and down. Let us give them some appropriate names. So let's name this first as Amazon.close, second variable as delta, same, third as up, and fourth as down. So these are our relevant variables in the Amazon RSI variable. Let's see if the variable is created properly or something is to be done. So we can see the variable is created. Since there are some NA observations, let's remove these NAs for a clean operation with our good old na.omit command. Now we'll fill up the up and down value. That is also easy. So we'll use our Amazon RSI measure. We'll create a new variable, which is, first we have up value. Let's call this up value, which is simply equal to Amazon closing price into the up value. In a very similar manner, we'll create the down value. We'll create the down value as well. As you would have guessed already, it is closing price multiplied by down value. So now we have up and down values. In the next step, we'll take the average of these values. Let's see how this is done. So probably we'll use a moving average of 14 days maybe. So let's see how it is done. So we'll use, let's call it up average, which is simply the average of previous, let's say we use 14 days values. So we'll use this roll apply command. Through this roll apply command, what we'll do is we'll take this up value and select an interval of 14 days. So the moving average of 14-day up value is created. We need to supply the function mean. Function is mean. Fill, so not available, so those will be filled with NAs, and NA.RM is equal to true. So NA observation should not affect our estimation. So first, in this manner, we'll compute the up averages for 14 days. Similarly, and please note, where the value is down, it is taken as 0. Similarly, we'll compute, so there you will have 0 in the data. Similarly, we'll compute for down value. Not that difficult. Again, the same set of commands, only that instead of up, we'll use down. Now that our variable is created, let's clean it for any NA observations. So we'll again go back to our good old NA.omit friend. Let's see, let's check the head of the observations to see if the variables are created. Yes, they are. Up and down averages are created. So now as a last step, we need to compute the relative strength, which will transform later into RSI measure. Let's see how it is done. So first, let's call it RS, relative strength, and this is nothing but Amazon relative strength up averages divided by Amazon down averages. So this is our relative strength measure. Now very easily we can compute the final relative strength variable. Let's call it RSI, relative strength indicator, and the formula is simple. It's 100 minus, and because of this formula, if you recall from the discussion in the theoretical in the classes, the theoretical discussion we had, how this formula helps us in getting a very nicely behaving RSI measure. We'll discuss and see some of the properties shortly. So this way this measure is created. Now if I take the head, let's see the head if the measure is created. Yes, it is indeed created, and let me show you something interesting. So let me show you the summary of this RSI measure that we have created. Something interesting. So if you notice, this measure moves between 0 to 100. A lower value and higher value, higher and lower limits are 0 to 100, and therefore, as we can see, this in this particular case, it moves from 14. The way it is constructed, it will move from 0 to 100. A value would indicate that this RS relative strength was 0. When relative strength is 0, you will get a value of 0, and when this relative strength indicator is very high, tending to very large values, then you would get a value of 100. So it varies between 0 to 100. A high value would indicate a very high momentum, like 86 would indicate a very high momentum on the very top of it, and minimum values would indicate low momentum. So in this video, we saw how to construct RSI. In the next video, we'll see how to visualize the RSI measure. In this video, we'll learn how to visualize the RSI indicator that we constructed earlier. So we'll learn how to visualize the RSI indicator. We'll use the title of the graph as title 1. Let's call it Amazon RSI. So let's use this name. Next we'll create the plot with plot command. Let's create some space so that it is visible. So in the plot command I'll use this is our index date. Next we'll give x-axis as date and we'll use should specify y as this indicator we created earlier, this variable RSI variable which hovers between somewhere around 15 to 85. Now let's put the y-axis name as ylab as RSI. The name should be explanatory so that user can understand what exactly is being plotted. 14-day moving average. So it's the 14-day moving average RSI measure. Now specify the y limit. So as we are aware that it moves from 0 to 100. So we'll specify 0 to 100 and it is a line plot. So we'll create a type equal to L. Now please recall that you need to find some signal lines that when they are crossed the signal is generated. So first main equal. So what we'll do is we'll use this paste command, paste title 1. So this paste title 1 will give us the title. Let's see what exactly it does. So it will, oh, I need to run this and then probably it will run better. So yes, you have Amazon RSI. Either way I could have given it directly as well. For example, I could have specified here the title as well. That is also fine. So now one important thing that we need to do here is we need to add one abline command. The role of this abline command here is that I specify the upper and lower signal lines. For example, here I'm specifying the signal lines at 30 and 70. So if the line moves, if these will be horizontal lines specifically, and what will happen is let me give it line width of 2 and color equal to blue. So what will happen is that when this plot is created, there will be a signal line on the up and down like this. Okay, let me type. I put line type is 4. Oh, I wanted line width. I wanted line width to be slightly. Now it's better. So I by mistake I was using LTY. It should have been LWD. The way to interpret this chart is that when this signal line, the line which is fluctuating a lot, which is RSI line, when it crosses, it goes above, it is at a very high level. You expect it like a car rolling down the hill. You expect it to fall when it is crossing from above the upper line, and when it is crossing from below the lower line, you would expect it to rise. So when it is crossing the 30 line at 30 point from below to above, it is expected to rise, and as we can see, it is happening many times. And when it is falling above, crossing from above to below the line at 70, it is expected to fall. Now the upper and lower limits we should specify depending upon experience with the plots. For example, in this case 30 and 70 seems to be a good fit, but depending upon your experience and frequency and the kind of average you have taken, you can change it to, let's say, 80-20 as well. In this plot, what if we wanted to focus on a particular range of x? Let's say we wanted to focus on the year 2020. Then we would use the same set of command, but we'll make some extra changes. First and foremost, we'll specify the range that we want to use, range of x, which is equal to, let's put it as dot date, and we'll use the limit dates. Our dates are 2020. So 1st January 2020, and the closing limit of this range is 2020, but now it is December 31st. So this is the range we'll use. And also we have specified the title one. We'll also specify subtitle 2, which we'll use as a next line kind of title. We'll specify that we are using Jan 2020 to deck 2020. Now we'll go back to our plot command, and the only change now we are going to do, we need to add, so in this case we'll need to use the paste command to add our title. So we'll put it like this, so the title 1 first, and then we'll specify next line, which means that the next line of title should come in the next line, and here after this we'll put title 2. So one slight change, sometimes while plotting this you may not want the color to be, let's say, blue only. You may want to change for lower line blue and then higher line may be red. So for those kind of changes I'll specify that the other line should be red. So now this vector command would specify the two lines have separate colors. Let's run this. So first we have specified the range, we have given the title 1, title 2, and then we need to specify the plot command. So we'll run the plot command, and you can see now nicely plotted. One more, it looks like this. You can zoom it out and you can see when it crosses the upper line and comes back, that is a clear signal of falling prices. Momentum is falling down like a car rolling down the hill. And similarly, when it crosses from below the 30 line, when it crosses from below 30 line to on the upside, that means the car is now at the bottom and going to move up. There's a lot of upside momentum in the car. And when it is moving from above to below, crossing at 70, that means the car is falling now. So that's a downside momentum. So this is how you understand this RSI plot. Till now we have been constructing these plots from brick by brick, piece by piece, in a very linear manner. Next we'll use the functionalities of Quantmod like chart series and some advanced plot to see how with a simple single line, that's 1-2 line codes, we can prepare these complex diagrams in a very aesthetic manner. In this video we'll understand the advanced techniques using Quantmod package. So session 2, Quantmod. So what you need to do is, first you need to add this library Quantmod, and now you are ready. So we have already downloaded the Apple data. If you recall, we have already downloaded the Apple data, and this data, basically this was downloaded from Quantmod package get symbols only, so I will not repeat that. Let's start with some basic steps. With some useful commands you can extract various columns. Let's see how it is done. For example, you can extract the open prices using this op Apple command. So you can check the head of open. So this is the open price. Similarly, you can extract the high price using high function, high. So you can extract the high price. You can extract in a very similar manner, you can extract, you can run the head of high, you can extract the low with this useful command low, and you can see if you have extracted it properly. Then you have closing. You can also extract the closing, close, it's called CL close, and you can check if you have extracted it properly with this close function. You can also extract volume. Let's call it volume equal to volume APL. You can extract that. You can check with head if you have extracted the volume correctly. Yes, you have done. Lastly, we have adjusted close. You can extract the adjusted close with this AD function. You have APL head adjusted close. We have done that. Often you need to aggregate measures like volume, prices from weekly to yearly basis. So let me show you how to aggregate, starting with volume series. The procedure for price and other measures pretty similar. So I'll show you how to aggregate series. Currently we have downloaded daily data for volume. So let's say we want to aggregate it for monthly volume. Then you use this command apply dot monthly and you provide your volume measure that you have just computed. I'll use the function VO APL. VO here you can use VO also, and you wanted sum. So if you wanted sum, you can just put sum. You could have put other functions like mean and so on, but we wanted sum to aggregate, so we run that. Then similarly you wanted to sum for quarterly, so let's call it quarter, QTR, quarter volume. And now instead of apply monthly, I'll use the apply quarterly. I can check the apply quarterly. I can do that. Similarly, I can apply yearly. Let's call it yearly, and I'll use the apply yearly function. This will aggregate the series to yearly, and this to that extent that your series is continuous without missing observations, your results will be fairly accurate. You wanted to apply weekly, you have the option to apply it for, let's call it weekly, so that is also available. You can aggregate it to weekly series, and so on. You can see you can aggregate the series. Similarly, you can aggregate price series and so on. So in this series we saw how to work around with different attributes of the share prices downloaded from Yahoo Finance with Quantmod package. In the next step we will start with the advanced plotting using chart series function. In this video we'll learn how to plot nice plots with price volume using chart series function. So let's start with a simple chart series plot. So you have chart series function where first you provide the price series that you want to use in OHLC form. Then let's say you want a line type plot. So let's start with a very simple line type plot. Also you need to specify the period for which you want to plot. So let's say you plot for a period of, you want to plot a particular period, let's say 2010, maybe May 2010 to 2020, maybe 2020 June. So this is your plotting period. Now you need to specify the theme. So maybe I'll use a white theme. We'll see what are other options. So theme equal to white. Let's see what it gives us. A small adjustment. So this is my period. Let me see. So this is a very nice plot that we have received here. Let's say you want to zoom on a particular period, so you can use this zoom chart, and there you can specify a different period. So then with chart it will provide you with the zooming functionality. Let's say instead of that you wanted to be fixed on 2019, that also is possible here. So you can zoom on a particular section, so you can plot it and then you can zoom on it. Also so this was line plot. Let us see what other options do we have. So first, also we can, instead of white, you can use the black theme. Let me see if black theme is available. Yep, so it appears like this, but we'll stick to the white theme. And in the next, let's see what happens if we put type as by default. Let's say what is the default plot. So it seems the default is this kind of bar kind of plot. So default is like bar. So you have bar as default. If you want to check what are other options available to you, so you can see this chart series command, and what are the options available to us. So it's auto seems by default, bars, line, candlestick, match 6. So let's try some other combinations. So we'll use maybe type as auto. Let's see what happens. What do we get here? So it's, yep, so it seems, let's zoom on the chart, kind of bars only, similar to bars theme. Let's see if I specifically put bar, then also very similar looking plot I get, or something different. So let me plot it. So this is a slightly different, if you recall the theoretical discussion, these bars, opening, closing bars and so on. So it's a nice plot. Then I can Also there are some other versions, let me show you. So you have matchstick and candlestick. Candlestick is more famous, so I'll start with candlestick. It's rather more famous and more a higher utility. We'll see that when I plot it. So see, if when I zoom it, by default you have red and green colors. You can change it. So the red bars are the falling prices and green bars are the rising one. You can see the volume and prices. Refer to the class discussions to make more sense of this candlestick plot. Then lastly we have matchstick plot. So we'll see, you have matchsticks. Let us see how it works. So matchsticks, so matchstick also very similar to bars, but they have the, you can see there again the red ones are falling and green ones are rising, so it gives you some idea of how things work. So in this video we have plotted very nice plots with price volume data, OHLC and price volume data, some very nice plots using chart series function. In the next video we'll see how to add more complex technical indicators in the same chart series plot using the same chart series function. In this video we'll see how to add technical trading indicators with the help of TTR package, and we'll also see how to visualize them in a simple manner. So we'll add technical indicators with TTR package. So we need to add library TTR. Now let's compute some of the technical trading indicators, starting with simple moving average, simple MA, simple moving average, let's call it SMA, and we'll create simple moving average using the closing price series of Apple and we need to give how many days of moving average we want. So let's specify as 20. So our indicator is created. Let's see how it appears. So let's use head SMA. So the indicator is there. Use tail MA. Let's see if there are some items here. Yes, so I can use our na.omit with SMA, and also I can plot this, and in the plot I can specify that this is SMA plot. So you can see the SMA plot, moving average plot. Similarly I can plot Bollinger bands. How to do it? Put simply, I can create this Bollinger band series, B bands. Again we'll specify that we want to use closing prices on Apple. You can use Apple, Amazon, and so any series. Next I need to specify that we need a standard deviation of 2, and also you need to specify apart from standard deviation how many numbers you need series. So we have computed the BB series. And now let's see if it is working. So let's see if it is working. The next step is to plot BB, and let's give the name as main equal to Bollinger bands. Let's see. So we have a nice plot here with a nice colorful plot. You have Bollinger bands on up and down, so you can plot this graph and nicely see how it behaves. For theoretical discussion you can go back to the PPTs where we discussed in a more theoretical manner. Now let's see how to add momentum. So we want to compute the momentum. Let's use the momentum indicator. So we'll momentum indicator. So we'll create, let's say, M equal to momentum, and we'll add again the closing price of Apple for, and momentum for maybe 5 days kind of momentum we'll use. Let's plot the momentum. So this is the momentum plot which reflects the momentum on the up or down side. Also you can use as a momentum indicator ROC oscillator. So ROC momentum indicator, very easy. Simply we use ROC equal to, again, the ROC function. I'll use closing Apple series, again maybe 5 days of ROC series. Let's plot and let's give the name as ROC indicator. Let's see if it is yes. So this is ROC indicator. Similarly, we have moving average, convergence, divergence. For a real discussion, we can refer to the theoretical videos where we discuss the fundamentals to these. So let's start with MACD indicator. Again, we'll use MACD command in the TTR package. We need to specify the closing price series that we want to use. Also, you need to provide a fast and slow signal line. So fast line for 12 days generally. So you have fast line for 12 days and slow line. Let's use the slow line for 26 days. So slow line is supposed to be for higher days so that it's more slower. The higher the period, the slower it is. And then the signal generation line. Let's use the signal generation line for maybe 9 days. And we'll add the MA type as SMA, simple moving average for MACD. You can use exponential or any other variant. So we are using this simple moving average. And then let's plot this MACD. So we adjust the numbers a little bit. I use signal line as 100, slow line as 200, so to make the graph more visible. And when I plot the graph, let's just focus on this. The red line, the more fluctuating line is the black line, which is a MACD line, and the red line is the signal line. So when this is crossed over, when the signal line is crossed over from above or below, you understand the signal is generated. For example, when it is crossed from above towards the moving average line crosses it from above to below, that means now the momentum is falling. Similarly, when it is crossing it from below to above, that means momentum is rising. Lastly, let's also try RSI indicator. Rather than writing those lengthier codes, we'll simply, to plot RSI, we'll simply use this RSI command and again supply the closing price and add it within 14, maybe 14. We'll try some more if it doesn't work. So we can then plot RSI. We'll give the name as RSI indicator. We can plot it. Now this is the RSI plot. You can decide based on your comfort. You can decide the crossing line. For example, here let's say I decide that 70-30 is my crossing line. So whenever this RSI indicator crosses from above to below the 70 line, that means momentum is falling, and similarly when it crosses from below to above the 30 line, that also means momentum is rising, as we discussed earlier also. So here you can identify some of the signal generations. You can identify trend reversals, patterns, and so on. So in this video we understood how to compute these indicators using TTR package. In the next video we'll make use of chart series plot to create some more complex plots with indicators. In this video, we'll combine our learnings of TTR package, technical trading package TTR, to compute the technical indicators, as well as chart series package to create more complex plots of technical indicators. So let's start with the charting exercise. Let's start with simple SMA plot, and then we'll move on, increase the complexity, so to say. So we'll first compute. We have already seen that this is quite simple. We'll use this SMA function and CL and Apple, and we specified that n should be maybe equal to 20. Now with this, let's use our good old chart series plot. In the chart series plot, we'll specify Apple series. We'll specify the subset period as maybe 2019 January up till 2019 December. So this is the period that we are using, and let's add a theme as white. So this is our plot. Let's see if it is working. Okay, so I should have put here chart series rather than chart series plot. Let's see if our plot is working. Yes, so the plot is there. Now let's add one by one indicators. So first let us add simple moving average, and it's pretty simple. We just put n equal to 20 as we wanted, on equal to 1, call equal to blue. So this will add first a rather fast moving average of smaller period. Similarly, we can add on another indicator with n equal to 200. So this will be rather more slow, and probably we should change the color to red. And you can see it's much more slow. It's almost, now you can use these SMAs in conjunction. You can zoom the plot, and for example you can wait for the price to cross over one of the indicators, and similarly the blue ones, or you can also compare between two SMAs, let's say blue versus red. The blue one is obviously faster because small period, and when it crosses over, signal is generated, but the actual action appears from the price itself. So now let's quickly look at some of the other indicators, charting other indicators. For example, instead of MA, early in this plot we were focusing on SMA. Let's do for EMA. The commands are rather simple. So all I need to do, I need to just, instead of add SMA, I should just add EMA. And let me see how it works. So I've made a small change. Instead of SMA, I have added EMA, so that you can add. You can see EMA is slightly more capturing the upward movement because the name suggests exponential moving average, so it gives more weighted to recent changes. Similarly, I can compute Bollinger bands. Again, for Bollinger bands, we'll use the same plot, chart series plot. All we are doing, instead of adding one indicator, we are referring to another. So let's say add Bollinger bands, and I need to just specify the period and standard deviation of 2. Let's see, let's create the plot fresh. Let me put the heading Bollinger bands. Let's see how to add them. Simple plot, and you can see the bands are added, and you can see wherever, you can zoom the plot and see whenever the price is crossing the band. On the lower side, when it is crossing over from above to below, a false signal is generated. When it is crossing from below to above, an upside signal is generated. Let's move to the next one, which is momentum. So let's add the momentum plot. Again, same old exercise. We copy the same codes. I do not rewrite the code. In the interest of time, I add momentum, and let's say specify a period of 5. We'll fit around the period to see how it works. So you can add the momentum. You can see the momentum is plotted below. When the price momentum is falling or going above, you can see that very nicely. As you increase the period, you notice the momentum will come more. You can add more and momentum, more and more plots. For example, 10, 15. So you can keep on adding momentum plot to see the performance. Next, let us add ROC plot to our chart. Again, very simple. So I'll add ROC plot. How to add it? Same old plot. First we select the, we plot the afresh the chart, and then we add ROC. In a very simple manner, I can specify maybe n equal to 5, or maybe I can specify n equal to 10. Let's see if it adds there. Yep. So I can keep on adding, increasing the period higher and higher, and find the plot. Maybe let's say 15. Add another layer, so we can do that. Next, we'll add, the rules of interpretation remains the same of any momentum indicator, only that its construction varies according to our requirements. Let's plot MACD indicator. All we do, again, we use the same chart command, and then we'll add the MACD line, MACD line. In the MACD line, first we need to provide the faster one. Let's start with 12. We'll change it later depending upon our requirements. Then slowest one, 26, and then the signal line, maybe 9 days, and let's keep the type as EMA to make it more fast. So let's plot the plot fresh. Let's change the indicators. So you can see it appearing at the bottom. For example, you can see when the line cross, for example, you can see the signal line in red and MACD line in 2 point on slightly gray color, and you can see whenever the signal line crosses the MACD line, a signal is generated. For example, here the MACD is crossing the signal line from below, that means upside signal, and price also shows upside movement. Similarly, whenever it crosses from above to below, a downside signal is generated like the one here. Let's try some other combinations. So maybe the fast one, let's keep the fast one as more fast and slow one as more slow, maybe 60, and the signal line to at 30. So let's see what happens. Yep, we get another. So you can see now, as we change the configuration, a sort of different line, a slightly more different line is appearing. As we can see, 12, 26, 9, 6, 60 and 30, you can see different line configuration, it generates more signals. So it's a trade-off. When your signal is, when you make your signal line more finicky for a larger period, and your signal line, the MACD line, to be more fluctuating, more signals are generated. But some of these signals, as we discussed in the theoretical lectures, can be whipsaws, false signals. So depending up, there's a trade-off. When more signals are there, many of them can be whipsaws. When less signals are there, these less signals are more efficient, but then you may miss out on profits many times. Now let's add another chart, which is RSI chart. Let's see how to do it. Again, very simple. We'll add RSI chart. Let's see how to do it. So for RSI chart, I'll copy the same plot command. So I'll create the plot afresh, and then I need to add the RSI. All I need to specify the period, maybe 14 days, and the type, MA type graph. What kind of MA I want to have? Maybe EMA we'll choose. We have seen SMA, let's choose the EMA, and the plot is added. You can change the period. For example, you can add RSI for 28 days, and you can see the comparison. Lastly, let me show you a more complex chart where we'll add multiple indicators. So complex chart, let's see how it is done. So again, let's have our original plot, but this time around, after plotting the fresh plot, we'll add number of indicators, starting with Bollinger bands. So for Bollinger bands, we need the argument number of days and standard deviation. So that is first addition. The second addition is RSI. So let's add RSI. What parameters do we need? Again, we'll stick to n equal to 20, same, and then I'll add MA type as EMA. So we have added another EMA, and then we'll also add MACD to increase the complexity and signal generation. So again, the fast one maybe 12, the slow one maybe 26, and signal generation maybe 30, and type as EMA. So let's see what it has given us. Okay, so all a very complex chart with many indicators to help us with our technical analysis. To summarize, in this lesson, we visualized the data and examined its various properties. For example, financial market returns do not follow normal distribution as often suggested in the theory. We also saw that its tail are fatter and more negatively skewed. With the help of moving average plots, we saw how to generate trends and trend reversal signals. We saw how to use a system of moving averages, a short-term and long-term moving average, to generate signals. In addition, we also saw the application of momentum indicators to generate trend and trend reversal signals. Momentum indicators are very useful in generating reliable signals. We saw how these momentum indicators give us early warning signals before the actual price movement happens. Lastly, with the Quantmod and TTR package, we constructed complex momentum charts. These complex momentum charts are part of weight of evidence approach, that is, to which direction a higher weight of evidence points out. For example, whether a considerable evidence points towards trend continuation or reversal. That is what we try to gauge examining all these indicators.